Hello everyone, welcome to Learn Data Structures and Algorithm in Python course. In today's lecture, we'll be solving a Leetcode problem on stack. So it is called daily temperatures. First, you'll be given an array of integers called temperature. So here you can see represent the daily temperatures. Return an array answer array. You have to return an answer array such that each answer of I is the number of days you have to wait after ith day to get warmer temperature. That means, let's say this array. Okay, let's say this array. Okay, so if you observe carefully, so let's say first element is 73, right? Now you have to look at the right. You have to look at the right, and you have to tell how many days you have to wait to get warmer temperature. These are the temperatures of corresponding days. Now when we are at this position, so how many days we have to wait to get warmer temperature? Means we have to find the next greater element, right? For each element, we have to find the next greater element to it. Okay. So how many days we have to wait? So index of this, let's say 0, 1, 2, 3, 4, 5, 6, 7. So this is day 0, this is day 1, this is day 2, like that. Okay. Now at day 0, how many days we have to wait to get warmer temperature? What is the next greater element to it? It is 74, right? Now what is the index of it? 1, right? So that means 1 minus 0 means we have to wait for 1 days. Okay. Now when we are at this element, now tell me how many days we have to wait to get warmer temperature. We have to look at the right. Okay. First I have to find what is the next greater element of 74. So we got this one. Okay. So what is the index? Index is 2, and 2 minus 1 means 1. We have to wait for 1 day, right? Now when we are at element 75, index 2, now we have to look what is the next greater element of 75. So is 71 greater than 75? No, right? 69? No, right? 72? No, right? 76? Yes, 76 is greater than 75. Then how many days we have to wait? We have to wait 1, 2, 3, 4 days, right? That means index 6 minus index 2, that is basically 4. 4 days we have to wait. Then when we are at 71, when we are at index 3, now how many days we have to wait? 69? No, right? 72? Yes. That means 5 minus 3, basically 2. Okay, this is done. Then 79 for 69, how many days we have to wait? So next greater is 72, right? So index is 5. 5 minus 4 equals to 1, right? Now when we are at 72, how many days we have to wait? So next greater is 76, means 6 minus 5 equals to 1. Then when we are at 76, how many days we have to wait? So 73. Then no elements are there, right? That means we have not find any greater element of this 75, right? Then we have to return 0. So if we couldn't find any element that is greater than current element, then we have to return 0. Okay, then what is next? The next is 73. So are there any element next to it? No, right? That means again we have to return 0. So that means 1142, 1142, 1100, 1100. So now hope you understand the problem. So for this one also, if it is 30, so next greater element is 40, right? How many days we have to wait? We have to wait for 1 days. Like for 40 to 50, we have to wait for 1 days. To 50 to 60, we have to wait for 1 days. For 60, there is no such element. That's why we are returning 0, right? Now how to solve this problem? To solve this, so this is basically an application of next greater, right? Next greater. So how we can solve this? We can solve this using stack. So first what we have to do first, we'll be taking a stack. Okay, we'll be taking a stack. Then what is the next step? We'll be iterating from the last. First we'll be check for this element. Okay, so we'll be doing from this last. Okay, so let's say we are at n minus 1 element, right? So index number 7. Then what we'll check? We'll check at the stack. We'll check at the stack. So is there any element? Is there any element smaller to this? No, right? Because stack is empty. So the stack is empty means in the right, we couldn't find anything, right? That means we have to return 0 here. Okay, we have to return 0 here. Okay, then what will the next step? In the previous problem, we have seen we were storing this element itself, right? 73 itself. But here, what we store? We will be storing the index. We'll be storing the index. What is the index of it? 7. Why we are storing the index? Because we have to calculate the difference. We are not returning the element, right? We are returning the difference of it. How many days it will require to get the warmer temperature, right? That's why we are storing the index. Okay, 7 is done. Then we will be moved to this element, whatever the next to it. Okay, here will be here. Then what we'll check? Okay, we'll check. So at the stack, at the peak of the stack, whatever the index, so let's say this is temp array, temp array. So what we'll check, whatever the peak element, so st peak element means -1, right? So temp of this peak element, because we are dealing with the index, right? We are dealing with the index. So is the peak element is less than our current element? What is current element? Let's assume I. Okay. So is the peak element is less than current element? If we find this condition is true, this condition is true, that means whatever element present in the stack that is less than our current element, then what we'll do will be pop this out. So index 7, so index 7 means 73, right? And current element, what is the index? Index is 6, right? So temp at 6. So is this element smaller than this? Yes, right? Then what we'll do, we'll just pop this thing. We'll just pop this thing. Okay. Then what we'll do? Then we'll check again if this peak element. So is there any peak element? No, right? That means we'll be returning 0 here. Okay. This is done. Then we'll be moving to next element. Next element here. Now we'll check. Now we'll check. Okay. So before going to this index, whatever the current element that will push here. So 6 will be here. 7 has removed, 6 is there. Okay. Then what we'll do? We'll be going to this element. Okay. Index number 5. Then we'll check if the element at this stack, peak of this stack, that means at index number 6. What is index number 6? 76. Is this 76 less than 72? No, right? No. Then what we'll do? Whatever the peak element. So now peak is 6, right? Peak is 6. Now try to understand. Peak is 6. And current is 5. Current element is 5. Index of this current element is 5. And whatever the peak is 6. Now tell me, we have find an element that is greater than this is at this index. Okay. Now how many days we have to wait? It is nothing but simply will be will be will be subtracting this. Means we'll be subtracting 6 minus 5. That means st of peak minus current index. Okay, this will be our answer. So 6 minus 5, that means 1. Okay, till now this is done. Okay, then what is the current element? 5. So we'll be pushing the 5 here. Okay, then what is the next step? Next step, we'll be moving our pointer. We'll be moving our pointer here for this element, for index number 4. Now we'll check. The element at the peak of the stack is less than current element. So means, so index number 5, that means this one 72. Is 72 less than current element? No, right? Then what we'll do? Whatever the peak element minus current element, that means 5 minus 4 equals to 1. That will be storing here. We are dealing with index here. We are not dealing with element, right? Then what we'll do? We'll just store current index here. Okay, index number 4 here. We are not storing element. Okay. Now this is done. We'll move our pointer to here, right? Now here we'll check. So element at 4 is less than current element. Yes, right? 69 is less than 71. Then what we'll do? We'll just remove this thing, pop this out. Okay, then again we'll check. Element is at 5. Element at index 5. So element at index 5, is it is less than 71? No, right? No. That means we have to return 5 minus current index. 5 minus 3, that is 2. So if you calculate, so we have to wait 2 days, right? 1 2 2 days to get warmer temperature. Okay, now what we'll do, we'll push 3 here. Okay, now we'll be move to next element. What is our next element? 2, right? 2. Now what we'll check, whatever is the peak. Peak is 3, right? That means we'll be comparing this with this. So is 71 less than 75? Yes, right? Then what we'll do, we'll be pop this. Okay, pop this, pop this. Okay, then we'll check what is in the peak. 5, right? So at index 5, what is the element? 72. Now we'll compare. Is 72 is less than 75? Yes, right? Then what we'll do, again we'll pop this thing, again we'll pop this thing, again we'll pop this. Okay, pop this means we have not find any greater element till now. Now what is the next element? Index 6, right? So index 6, that means this element. So now we compare. Is this 76 less than 75? No, right? Then no. That means we get our answer. That means whatever the peak element, this is index 6. And what is the current index? Index 2, right? Index 2. That is 6 minus 2 equals to 4. 4 will be our answer. If you check, so we have to wait for 1, 2, 3, 4 days. That means we are correct. Okay. Till now this is fine. Then next we'll be moving to this element. Okay, now what is it? 74. So before doing that, we'll be storing 2. Okay, the current index. Okay, 74. Now we'll check what is the peak index. 2, right? So we'll be comparing this with this. So is 75 less than 74? No, right? That means we get our answer. So what is the difference? Difference is 2 minus 1, because peak is 2, current is 1, right? So what will be the answer? Answer will be 1, right? Then this is done. We'll be storing 1 here. We'll be storing 1 here. Then we'll be move to our next pointer. What is next? Next is the 73. That means index 0. Then we'll check what is the peak index. 1, right? So this means we'll be comparing this with this. Is 74 less than 73? No, right? That means we get our answer. So what is the peak index? Peak index is 1. And what is the current? Current is 0. And so what will be the answer? 1 minus 0 equals to 1. So we got our resultant array, right? Resultant array. Now let's see how we can write the code for this problem. So this is the function for this. So let's rename it temp. Okay, now let's take a variable. Let's take in equals to length of this temperature array. Okay, now what we'll do, we'll be maintaining a resultant array. But here the problem is, we are pushing the element, we are storing the element from the end, right? From the end, right? So to do that, first we'll be creating an empty array. First we'll be creating an empty array and fill with 0. Fill all with 0. And what will be the length? The length will be exact the same as temperature array. So first let's take a create an resultant array. Array is equals to, let's fill it with 0 and it will be of n size. Okay, then let's take a stack empty stack. Okay, then we'll be doing the operation from the end, right? From the end, we'll be doing the operation from the end, means we'll be starting from n minus 1, we'll go up to 0, right? And we'll be decrementing the index. So let's run a for loop. So for I in range, and range will be starting from n minus 1 to minus 1. That means minus 1 will be excluded and will be decrementing the index, right? So that is done. Then what will check? We'll check while stack is not empty. And so what will be the peak of the stack? That will be basically index, right? Now to check the element, what we have to do, we have to check with the index. So index will be st of peak. So whatever element at the peak, if that is less than our current element, right? So what will be the current element? Current element will be temp of I, right? Because I is our current element. So if it is less than or equals to this, Then what we'll do will be pop this thing. So st dot pop. Done. Okay. Then so when it is done, then we'll check if the stack is not empty. Then what we'll do? Then the current result will be, because we are storing from the end, right? That's why we are just writing res of I. Otherwise we just directly append this thing, because we are filling from the end. So when we are at n minus 1, when we are at n minus 1, let's say we are at last element, then whatever the resultant array, in that element will be pushing the result, right? That's why we are writing res of I. Okay, res of I equals to will be st of last, so whatever the peak index minus current index. Okay, done. Otherwise will be storing 0. So otherwise raise of 0, sorry, raise of I will be 0, right? This is done. Then what we'll do, we'll push the current index at the stack. So st dot append current index is I. Done. Then at last we'll be returning this raise, right? So this is the whole code. So let's try to run this. Okay, this is accepted. Now let's try to submit this. Okay, now you can see this is accepted. So this was the problem. I hope now you have understood.